In this video, I will show you how the read ahead is working in SQL Server, how the optimizer is used this mechanism to boost the performance. So let's move to the SQL Server storage engine. So this is the SQL Server and we are in the query analyzer. We have the this table known as the product. On this table we have an index. This is a primary key cluster index on this table, and this is the column for which is the key for the index. And after creating the index, when we are checking the structure of the index by using this C metadata uh, dbcc command, we can find out the SQL server will find the IAM from this. This is the IAM, and here SQL Server knows that the root page starting from 1087. This is the file index ID. Index ID one mean this is the cluster index, and this index on this object ID, which is a products table ID, and allocation units are these are the allocated units to this index, and the root page starting from this one 1087, and first page is 224. And now the from the storage engine, one will go to the metadata for IAM, it will find from there this root page. Now the root page storage engine find out, and if we are going to check in detail the structure, index structure of this product table, then this we can find out by using this ind dbcc command. This is the full view it's showing us about this index structure, all these pages IDs which are assigned to this index structure. And this is a file ID where this index exists on this disk in this file, and this is the object ID, which is the ID of this product table, and this is the index ID. Index ID means this is the one is clustered index. And now these are the page type IDs. So the 10, if page type ID is 10, it means this is the IAM page, this is the allocation map page. And page type if 1, it means this is the leaf level page, this is the data page. And page ID 2 mean this is the index page, intermediate page. So this now the index level page type 2 mean this is a index page, and now the next column is index level. So 0 level mean this is the leaf level. So this is the leaf level. 0, if the 0, then it means this is the leaf level, and 1 means this is the index level. Index 0 means this is the leaf level, and on the leaf level we can find out on this cluster index that all are the uh, page type IDs 1, which mean data pages. All are on 0 level are the data pages. And if the index level 1, which is intermediate level index level, we can find out there is the index pages exist on this level 1. Index pages are exist. So now storage engine can if I will copy this structure into the Excel, I can, it's easy to study there. In this Excel I copied that data here, index data. Now from this storage engine we have discussed in the this read ahead, storage engine will go to the leaf level, intermediate level. After the this root level, it will traverse down to the intermediate level, and it will start uh, fetching these index pages which is are required to pick these leaf level data pages to fulfill the requirement of these queries. So now the storage engine first on this index level, and it's doing the index page scanning. So this level is one level, and if I will filter this one level from this, which is a intermediate level. Now on this level I can find that the pages assigned to this product table index structure, there are 1 2 3 4 pages are assigned at this level. Please note then that this level, which is the intermediate level, at this level, there are 4 pages assigned to this product table index structure. So there are 4 index pages. And this is the index level 1 mean this is intermediate level, and this page type 2 mean these are the index pages. So now this is first page is 232, which is the index page, and the in the header of this page the next logical page is the 1088. So storage engine will when scan all this page and this all the record on this page, storage engine will read, then it will go to the header and it will check the what is the next page ID in this page header. So the next page ID is 1088. This is the next logical page of this page 23 page, and then it will go to the 1088 which is here, and then the 1088 page storage engine will check what when it will read all the uh, records from this page, and then when the records will finish, storage engine will go to the header of this page and it will find the what is the next page is 638. Okay, then the storage engine will read the 638 into the memory, and this 638 page when it will read all this page, and then it will storage engine will go to the header of this page and it will find what is the next logical page. The next logical page is 1540. Then storage engine will go to the 1540 and it will read this page into the memory, and when it will read all the records from this page, and then the storage engine will go to the header of this page and to check the what is the next page. There is no next page, so storage engine will know that there is no more index pages at this level. At this intermediate level there is no more index pages. So now we can find out that this is the page ID and this is the next logical page ID after this page. So and we can find out that logical order and physical order are not matching, because this is the logically the next page is 1088, but physically it is not that, it is somewhere else. On the disk it may be it's coming after 638. So physically these pages are not contiguous, and then when the storage engine will read these pages which are required to fulfill that query in the memory. Now storage engine read these pages into the memory. This read storage engine read these pages into the memory, and while reading these pages, so storage engine reading these pages, doing the okay, this is the page 232. Storage engineer read the page into the memory and checking what is the next page, and checking out what this page is have some contiguous physical page. The next page, which is the logical page, is also physical page. Storage engine doing all this activity, and during this activity when storage engine will read this page and doing the next one, the another thread will be started. That thread will check that this index page is okay. In index pages what the pages are required to fulfill this query. This page is still not required. It will be required at later time when the query processing will be started. At this time the index scanning is doing on, but the intelligent method will start another thread, and the page index page which read into the memory, it will go to the dead page and it will check okay, what are the leaf level pages, what are the data pages required for this index pages. It will start reading in advance those pages. Suppose this is the page index page ID 232. If I will check what are the leaf level pages belongs to this page, I will go here. I will check I will switch on this trace on flag to check the data pages belongs to this 638. 638 is the index page. We can write the 232 also, or we can write that 638. These all are index pages. So I will write this. When I will execute this dbcc command, page command. So now this is the 232 is the index page, and this page have child pages, and this child pages level is 1, which means that these are the leaf level pages, these are the data pages. So this one index page have now this much. How many index pages? These all 269 pages are exist on this index level page. So this index level contains more than 260 leaf level pages addresses. So storage engine will start another thread. It will start reading these child pages in advance into the memory. So when later stages the query processing will start, all the pages which are required to fulfill this query will be in the buffer cache, so that at that time when it will start processing the query, the physical read should not be started, which will affect the performance. So in this way read ahead is working. Now if I will execute this query, first I will clear the buffer, all this cache I cleared. If I will execute this product query and I will check the I will on this input output statistics, so that statistics will show what is going on. And now if I will check this query this result, it is showing that there are 1164 read ahead. This read ahead mean the engine reading the records, the leaf level record in advance into the memory, so that to boost the performance of the query. So this is the read ahead mechanism.